So continuing with my critical numbers here, I put them on a number line to determine the intervals of increase and decrease. Here's my derivative here. Let's factor that. I take a 5 out, and I get this. So I'm going to do test values. I'll just do them mentally. I'm plugging in, say, -2 over here. That will give me positive. So I'm increasing here. If I plug in 0, hope you agree I get negative, so decreasing. And then if I'm bigger than 1, say +2, I'll get positive again. So there's my intervals of increase and decrease. And we move on to part F, which is local max and min values. So looking at our intervals of increase and decrease, we can see that there is a max here and a min appearing here. Let's find the corresponding y values. So f of -1 would be -1 to the 5 minus 5 times -1, which is -1 plus 5, which is 4. So in English we say local max at this point, -1, 4. That's this guy. Now we'll look at the minimum here. F of 1 is 1 to the 5 minus 5 times 1, giving me -4. So we have local min at 1, -4. Okay, now we need intervals of concavity and inflection points. Second derivative, f double prime of x is 20x cubed. So if this is 0, that can happen only if x is 0. And this thing always exists, so we don't have to worry about asymptotes or any kind of weirdness there. A nice simple polynomial here. So we got 0. And then test values. If I plug a negative number into my second derivative, I get a negative number, so concave down. And a positive number will yield a positive second derivative, concave up. Okay, now I'm ready to attempt a sketch. So let's go grab the important information which I've summarized over here. Let's go grab that and move it. What are you doing? What are you doing? Don't talk to me, tablet. I don't want to talk to you. Oh no, you are doing. Let's move it over here. Move it over here, move it over here. There we go. All right, this is the important information which we will use to draw our picture. Axes, bada boom, bada bing. So again, I have a quick look at these numbers to get an idea of what my scale should be. Not too big, not too small, just the size of Montreal. So 4s and 1s. So let's see. Why don't I put a 4 right about here. 4 is a nice number because the human eye can divide things in two pretty well. So I'm pretty good at, if I got 4 here, my eye is pretty good at finding 2. Not perfect, but it's pretty good. And then I'll put my 4 up here, and a 2, and a 4. Minus 4, minus 2. Okay, so I start, as always, by just putting these points onto my graph, just plotting those. So I got 0, 0, 1.5, and 0, and also negative 1.5 and 0. Those are intercepts. Negative 1, 4. Negative 1, 4. Doesn't have to be perfect. And then 1 and negative 4. 1 and negative 4. 1, negative 4. Right about there. Now, I can see my scale is a bit too cramped here. Thankfully, I'm on a tablet. I can just zoom in here when I do my more delicate drawing in a moment. Okay, so I got my points on there. Now I'll remember that this is a max and down here is a min. So I got a max here, and I have to go through this intercept. And I have to go through this intercept. So I'll zoom in nice and closely. And I'll try to make this happen. One more thing to keep in mind is that I have an IP down here. So I'll write IP beside it, because it's often tricky to make the IP come out nicely in your drawing. And the concavity switches there. Let's see how it switches. Concave, it goes from concave down to concave up. So I'm going to basically connect these 3 dots in a way that I have concave down here, switching to concave up at the origin. There's a max here. And I think that's all the information I need. So I'll zoom in nice and close here. And I'll try to make this happen. Oh, this is a bit tricky. So I'm going to go like this. Oh boy, bad start. It's okay. Use your eraser. Use a pencil. And just try to go concave down, 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 concave down, concave down, concave down, concave down, concave down, concave down, down, up, 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 up. We may have to fix this down here, but so far so good. Now I'm going to try to just get this to happen. Doesn't have to be perfect, but oh. And I don't want to go much further because it's going to not look good. Okay, so I think that's good. Okay, it is concave up. How about increase, decrease? Let's see here. It should be increasing, and then at -1 becomes decreasing. All right, looks good. Now I'm going to try to repeat the trick over here. So I want to go concave up, 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 concave up, concave up, concave up, concave up. Not too bad. Then I want to connect the dots, concave up, up, up. Oh, it's almost a straight line, but we will forgive and forget. Okay, I'm pretty happy with that. So often you just connect the dots quickly and intelligently. And then you just go back and check that your drawing makes sense with all the pertinent information over here. Okay, so again, the IP is tricky to get right. You know, I want it to be concave down here, then concave up here. That's tricky. So just make sure you put a little label there on your inflection point. Now, I want to talk about something before we move on. There is some symmetry here. Okay, you'll notice that this chunk is not exactly the mirror image, but if you take this chunk, reflect it over here, and then reflect it up here, then you will end up with this chunk here, right? Okay, so that's called what's called an odd function. An odd function. Function. Functoin. A functoin. No, a function, Jordan. Okay, odd function. Okay, the defining equation is that f of negative x is going to be a negative f of x. Okay, and you'll notice that my function, which is x to the 5 minus 5x, you can check it does indeed pass this test. Okay, so this can be helpful sometimes, because if you know that your function is odd, then you only have to sketch half of it, and then you can just use that mirror image idea to get the other half. So again, you could just take half of it, reflect in the y-axis to get something like this, and then reflect in the x-axis to get this piece here. So this would be part C above, if you want to do that. But generally, we don't require you to do that. Okay, there's also something called an even function. An even function would be if f of negative x is equal to just f of x, an example would be f of x equals x squared. Now this one truly exhibits symmetry, meaning that, oops, you know what I mean. If you take this arm reflected in the y-axis, you get this arm. Okay, so it's called an even function. Okay, so there you have it, even functions and odd functions. This can sometimes save you some time, but is not, strictly speaking, required.